Imagine AI models that don't just predict outcomes, but actually transform the way we approach drug discovery and material science. Sounds groundbreaking, right? Today, we're diving into AlphaProteo and Orb, two revolutionary AI models that are rewriting the rules of innovation. These aren't just algorithms, they're transforming industries in ways we never imagined. Excited to explore the future? Hit that subscribe button and join us on this incredible journey. Alright, you know how proteins are like the powerhouses of our bodies, right? They do everything from helping cells grow to boosting our immune systems, and they're central to nearly every biological process. But here's the catch. Proteins don't work in isolation. They interact with other proteins, like a key fitting into a lock. One protein binds to another, and that's how these critical functions happen inside our cells. Thanks to models like AlphaFold, we already have a solid grasp on how proteins interact. AlphaFold helps us predict what these interactions look like, which has been monumental for science. But here's the twist. While AlphaFold excels at figuring out how proteins connect, it doesn't create new proteins that can manipulate these interactions. And that's where the real magic happens. Enter AlphaProteo by Google DeepMind, the new AI system that's shaking things up. It doesn't just predict interactions, it designs entirely new proteins that can bind to specific target molecules. Why is this so transformational? Because these designed proteins, also known as binders, can accelerate everything from drug discovery to making crops more resilient to pests. Let's break it down. When you want to create a protein that binds tightly to a target, like a virus protein that causes COVID-19, it's not easy. Traditional methods are painstakingly slow. You have to create binders in the lab, test them, optimize, then test again. A never-ending cycle of trial and error. But with AlphaProteo, we're talking about a game-changing shortcut. This AI system has been trained on a massive dataset, including information from the protein data bank and more than 100 million predicted structures from AlphaFold. So yeah, it's learned a thing or two about how proteins interact. When you give AlphaProteo the structure of a target protein and specify where you want it to bind, it can instantly design a binder that fits nearly perfectly. It's like handing it the blueprint for a lock and having it design the perfect key. And it works on all kinds of proteins, cancer-related proteins, viral proteins like SARS-CoV-2, and even proteins associated with autoimmune diseases. So far, the results are mind-blowing. AlphaProteo generated binders for 7 different target proteins, and here's the kicker. They tested these binders in the lab, and the AI-designed ones worked like a charm. We're talking 300 to 300 times better binding strength than the best existing methods. Astonishing, right? Take, for instance, VEGF-A, a protein linked to cancer and diabetes complications. For the first time ever, AlphaProteo successfully designed a binder for VEGF-A, a major breakthrough. And it's not a one-off success. Consider BHRF1, a viral protein. 88% of AlphaProteo's candidate binders actually bound to BHRF1 successfully. On average, AlphaProteo's binders are 10 times stronger than the best designs we have today. One of the most exciting targets was the SARS-CoV-2 spike protein, the same spike that helps the virus infect our cells. And yes, AlphaProteo nailed it. It designed binders that were tested by top research groups like the Francis Crick Institute, and they confirmed the binders were legit. These binders even blocked the virus and its variants from infecting cells, which could play a role in future virus prevention. Now, this tech isn't flawless yet. For instance, AlphaProteo couldn't design a successful binder for TNF-A, a protein tied to autoimmune diseases like rheumatoid arthritis. But to be fair, TNF-A is notoriously difficult to bind, and the team picked it specifically to test the system's limits. So it's actually a good sign they're pushing boundaries. While strong binding is crucial, it's just the first step toward using these proteins for real-world applications, like drug design. There's still plenty of bioengineering work ahead, but AlphaProteo has already tackled one of the hardest parts. The team behind AlphaProteo is collaborating globally to make this system even better. They're also thinking carefully about biosecurity, ensuring this powerful tech is used for good, like developing treatments or cleaning the environment, rather than any questionable purposes. They're working with groups like the Nuclear Threat Initiative to ensure responsible use. And if you're wondering where this is headed, they're already exploring drug design applications with isomorphic labs and refining the algorithms to make the system even more versatile. They're not doing this alone. They're partnering with experts in machine learning, biochemistry, and structural biology. So the future of protein design? It's looking brighter than ever. Now, let's shift gears to another massive breakthrough in AI. Orb, the latest and greatest AI model for simulating advanced materials. Orb is open source, blazing fast, and is leaving tech giants like Google and Microsoft in the dust. If you're into AI, energy, or cutting-edge tech, this is for you. Imagine you're a scientist working on materials for better batteries or solar panels, crucial for the energy transition. To design these super-efficient materials, you need to know exactly what's happening at the atomic level, how atoms and molecules interact, what makes materials conduct energy better, or how to tweak them for efficiency. But here's the challenge. Traditional methods for simulating this are slow, costly, and often overly simplified. It's like trying to watch a 4K movie on dial-up internet. It's just not happening. And that's where AI, specifically Orb, steps in, giving us unprecedented detail without the wait. Built by a company called Orbital, Orb is designed to simulate materials at the atomic level faster and more accurately than anything else out there. And get this, it's based on a larger AI model they've been working on, called Linus. So they've been fine-tuning this for a while, and now it's paying off in a big way. Orb isn't just faster, it's 5 times faster than the best alternatives for large-scale simulations, a huge leap forward. And we're not just talking about outperforming random models. Orb is crushing Google's and Microsoft's models in both accuracy and speed. And here's the best part. They've open-sourced it. Yes, it's free for non-commercial uses, so startups and researchers looking to develop new materials can jump right in. You can even check out the full technical breakdown on their GitHub. Let me pause to explain why this is so significant. We're in the middle of a massive shift toward renewable energy, and materials are at the heart of that. Whether it's batteries for electric cars, solar panels, or semiconductors, the materials we use need to get better, more efficient, and longer lasting. The faster we can simulate and design these materials, the faster we can make them a reality. Orb is the tool that's going to supercharge that process. Now, if you're curious how Orb came to be, it all ties back to Linus. The team at Orbital has been training and refining Linus, and Orb is like Linus on steroids, specifically tuned for advanced material simulations. They've got a whole blog explaining the technical side if you want to dive in deeper. Can we just take a moment to appreciate the team behind Orb? This isn't a massive tech giant with endless resources. It's a small, highly motivated team that's competing with the likes of Google and Microsoft. It's a testament that in a world where it feels like only the giants can make big moves, a scrappy startup can still come out on top. So there you have it. Orb, the fastest and most accurate AI model for advanced material simulations, is out there and free to use for non-commercial purposes. I can't wait to see where this goes. Drop your thoughts in the comments. Are you as excited as I am? Smash that like button and subscribe for more deep dives into AI and tech. Thanks for watching, and I'll see you in the next one.